So question 5, we're given a circuit of 3 resistors in series, 24 volt battery, and we're given 3 points, and we're asked to find the voltage with respect to earth at each of these points. So we have resistor 1, resistor 2 and resistor 3. Here we got ground and we got the voltage. So we can say that point 1 with respect to ground, this is just coming from straight from the battery. There's no voltage drop across this. Point 1. That's just the supply voltage, which is 24 volts. And we got voltage at point 2. Well, that's equal to the supply voltage minus the supply current times the resistance of R1. That's the voltage drop. Because what's happened is the voltage is being dissipated in resistor R1. So we minus the voltage of the supply voltage against the voltage drop of resistor 1. So what we need for that is we need the supply current. And the supply current is the total resistance. So we need the total resistance, and we're dividing the supply voltage by the total resistance. So we go IS, the supply current, is equal to VS divided by the total resistance, which is 24 volts, divided by R1 plus R2 plus R3, and that is equal to 24 divided by 1000 plus 6800 plus 2200. If you do that sum, what you'll find is you get 2.4 milliamps. So now we can calculate P2. So point P2. So that was 24, so that's the supply voltage minus the voltage drop across R1, which is the supply current, 2.4 milliamps, times 1000. And that comes to 21.6 volts. So now we've got a voltage drop across R1, and we've got 21.6 volts going through R2. Well, what's the voltage drop across R2? Well, we can do the same again. So we have 0.3, and that is equal to the voltage across P2 minus the supply current times R2. It's equal to 21.6 volts minus 2.4 milliamps times 6.8 kilo ohms. And that comes to 5.28 volts. And as a sanity check, because what we want is Kirchhoff's voltage law, that all the voltage drops here will equal 0. Or I should say, all the voltage drops will equal the supply voltage. So if this all adds up to 0, then we're happy. So we'll add 0.4. So what I've done here is I've just added a point here, and I've gone 0.4, and that 0.4 should equal 0 if all has gone well. So 0.4 should equal 0, so that should equal 0.3 minus supply current times R3. 5.28 minus 2.4 milliamps times 2.2 kiloohms. And if you do that in your calculator, you'll see that that does equal 0 volts. So voltage law holds up, and we can say that our calculations are correct.